Okay, this is the slides and lecture from week 5 of the module, where we talked about process design. Quite a long, involved session it was, but what we'll do is we'll try and whiz through it. Okay, so the questions I asked you to think about, and which I'd like to think about when you're listening to this, are what do we mean by process design? What role does technology play in process design? I touched on that, and you obviously got the opportunity to think about that more yourselves. Human implications of process design. People are part of any operation and like to think a bit about how people interact with the technology and their behaviour is controlled by the process. What else have we got there? Okay, so how a process is designed in detail. Talked a little bit about mapping processes, and you can think about that. And finished with a bit about layouts and the basic layout types used in operation. Okay, so there's a transformation model, inputs, outputs. The inputs are divided into transformed and transform resources. As I keep saying, this is a great way of thinking about any operation and a good starting point. So if you have an operation in your assignment or want to describe an operation, this is a good way of thinking about how to make sense of it. Okay, and there's the transformation model. We've looked at last time at product and process and service design. So this week we're looking at process design and location layout and touch on flow. Okay, pick up on flow in a lot more detail in the deliver section. So what do we mean by process design? Well, we have 4 basic process types, and these are listed down the middle here: fixed position, process, sale and product. I'll pick up on all these later on when I talk about layout. So for now, the way of thinking about these is to array manufacturing types down one dimension and service process types down the other. And what we're doing here is we're dividing the operation by volume and variety. So those of the 4 V's, those 2 V's, volume and variety, are the principal ones which are important in thinking about designing the process of an operation. Okay, so broadly speaking, high variety and low volume are at the top of that chart. We've got projects and professional services on either side, and at the bottom of that chart we have very, very high volume and very low variety, mass services and continuous production, and array of things in between. Just like volume and variety I've shown you as continuums, so these are continuums as well. And so you need to, one of the things to point out here is I've got a rather false division between services and manufacturing. As I've implied throughout the module and given you examples of throughout the module so far, the two interact and overlap. So manufacturing, delivery of products which we consume go hand in hand with the services which are allied with them. Okay. Up at the top with very high variety, low volume activities, either services or projects which are delivery of products. We have very high flexibility, high variety of tasks. No movement. So normally the service or the project is delivered for the client or for the customer in a single place. Okay, these kind of activities, this process type is very, very costly. Moving down this range of process types, jobbing and batch activities, which I'll talk about in a moment, and service shop type activities still have quite high complex flows, relatively high flexibility, and low equipment utilization. So when I come on to talk about capacity is about utilization of facilities, and one of the aspects of capacity is utilization of facilities. And with these kind of activities, which are fairly high variety and low volume, the utilization is quite poor. Okay, moving down towards line production, mass production, batch production and service shop type activities. We have faster throughput. Often they have more equipment and facilities and cell production in particular, major plant reorganisations required. And then finally, in mass production type activities, continuous production activities, mass services, the flows are simple, the variety of tasks is relatively low and ordered. There's low cost per unit because you're producing large quantities or delivering large numbers of services, and they make use of specialised equipment. Okay, so project processes, fixed position processes. Here's some examples. They're often building projects or IT projects or engineering type projects. They tend to be one-off, complex, large scale, have high work content products. They're specially made, sometimes called unique, and everyone is customized to its location, to its customer requirements. One of the aspects which frequently distinguishes these from other kinds of operations is that they have a defined start and finish date. So they begin at a certain point, they finish at a certain point. So temporality or time is a key element of these kind of processes. Time and quality and cost objectives are crucial to these particular kinds of operational activities. If you do project management as a module, which I'm tackling next semester, or next term, then I'll go into a lot more detail, obviously, about these kind of processes. Lots of different skills are required, and these have to be coordinated by often a project manager or a project coordinator, operating normally from within a project office. Okay, jobbing processes, jobbing manufacturing comes in a variety of types. It's basically more greater volumes and slightly less variety than project type activities. So we've got here examples in these pictures of bespoke tailoring and Savile Row, that sort of thing, or precision made and bespoke furniture or carpentry might be examples. So very small quantities, often one-offs or in very small quantities, or only a few required. Specially made items, so we have high variety, low repetition. In the operations management language, we sometimes call these kind of products strangers. Where they have lots of customization within them, and you can find this in mass production as well. You have strangers in mass production as well, sometimes hand in hand with more repetitious activities. Skill requirements for these kind of manufacturing processes are normally very high and certainly very broad. Skilled jobbers or teams complete a whole product. So there we are. Batch processes. We've got a couple of examples here of electronics or specialist manufacturing, and there's a bakery up there making small batches of bread or loaves or something. Those are kind of examples. Higher volumes, as you'd expect, and low variety than for jobbing. We have standard products. Many standard products and repeat in demand. So obviously in a bakery you need lots of loaves, French sticks and bloomers and those kind of things which are required in relatively large quantities by the customers, and those are the sort of things which will be in high demand. But also special products will be required as well. So it's relatively specialised and narrow skills are required for these kind of activities. One of the features about these kind of processes is that setups or changeovers between different activities are often required at each stage in production. Okay, and then we have something we're all familiar with, mass production. So this kind of thing, we've got examples here of a beer factory or mass electronics. Equally, it could be car manufacturing, that's another common example. manufacturing of anything in bulk or large quantities. So much higher volumes than batch production, again, low variety. So we have standard repeat products, the same product being delivered time after time after time. And as opposed to strangers, this time we have runners. So that's the operations language for these kind of products. For these kind of activities, the skill set is pretty low and pretty narrow. There's no setups, so the process is set up once and then the same product is produced time after time after time. So there's no setups, or if there is a setup, it's almost instantaneous. Finally, we have continuous processes. Continuous processes are pretty much you press a button and off it goes. Got examples here of some kind of refinery maybe, or something with pipes in anyway. And the bottom one is paint production. Anything with often liquids, anything which is the very limited number of products which are produced in huge quantities through the process. So extremely high volumes, low variety, often only one single product or very few products. So a refinery will produce just a few different products from the oil which is pumped into it. Standard repeat products, runners, as I mentioned before. These are some of the features about both mass production and continuous processes is that they are very highly capital intensive. Mass production is becoming more and more capital intensive, automated in fact. And with automation, what we do is we see fewer and fewer people employed in these kind of manufacturing processes. Generally, no changeovers at all. There we are. The processes, something that's interesting about these processes is because they're continuous, to stop them is very expensive, and then to restart them is also very expensive. So they tend to run 24 hours a day, non-stop, and require continuous supply. Okay, so this is a key feature about these kind of processes. They need continuous supply of a product or some kind of ingredient or some kind of material which can be continually processed through them. And to stop them is incredibly expensive because you have to clean them out normally, and then to start them up again is also expensive. Okay. Okay, so turning our attention to services for a moment. As I say, the division between manufacturing and services is a little bit artificial. So, for example, projects often involve a huge number of services. Similarly, services often rely on products being as part of their overall delivery. But we'll stick with this division for the time being. So, for simplicity's sake, so professional services, probably something that a lot of you guys will end up participating in. Consultancy, architecture, those sort of things. Solicitors, lawyers, law, that kind of thing. Financial services are often professional services which are fairly client driven. We talk with customers in project type activities. We talk about clients as opposed to customers normally. Okay, we have high levels of customer or client contact, and that's a key feature of professional services. Clients spend a considerable part of time in the service process. So the clients are the customers and they are being transformed, but they're obviously part of the transformation process, and they spend a lot of time in that transformation process. Contact staff are given high levels of discretion in servicing their customers. So they are professionals often, and they have a lot of autonomy over the way they deliver the process, deliver the operation. These kind of activities require high levels of customization, just as projects do, with service processes being highly adaptable. They're people-based rather than equipment-based normally. Okay, Service shops, they're called service shops because often a shop is used as an example, but I've got two different examples here, hairdressing and a gym there. Those are two examples in those pictures. Here we have medium levels of volumes of customers, not huge numbers of customers, but a larger number of customers than you find in professional services. There's medium or mixed levels of customer contact. Obviously, for hairdressing, there's a relatively high level of customer contact. With gyms, there's a much smaller level of customer contact. Remember, this is a continuum. And service shops can range from relatively high volume and lower variety to relatively high variety and relatively low volume. And these are all encompassed within this process type called service shops. We have medium or mixed levels of customization, medium or mixed levels of staff discretion, and finally we have mass services. This is something which we're all familiar with. The obvious example is public transport. That's a very good example. But online banking or automated banking services are another very good example. And something you're all experiencing, lecture theatres and the lecture experience are another good example of mass services. So we have high volumes, levels of customers, low to medium levels of customer contact, low or mixed levels of customization, very little generally, and low or mixed levels of staff discretion. And there we are. So there's the volume of variety dimension. Down one side we have the manufacturing operations process types, projects, jobbing, batch, mass and continuous production. And on the other side we have the service operations process types, professional services, what we call broadly speaking service shops, and mass services. The interesting thing about this dimension, the reason it's shown in this kind of box shape, is because you can draw what's called a line of fit across this. Organisations can shift either side of that line if they want to provide more flexibility or more volume and less flexibility. So they can shift up and down that line, along that line, and either side of it. But really, if you go too far either side, you end up in a situation where the operation is hopelessly inefficient. More flexibility, process flexibility is needed, so higher cost. Low process flexibility required is needed, so also higher cost. Right, another way of thinking about operations is they go through a transition. In the initial innovation stage, they'll start off as prototypes or ideas or ways of thinking about how an operation might be delivered, and in that sense they tend to be with very high variety, fairly low volume, and fairly high cost. A good example is operations. At one time, Pioneer Surgery, the first heart surgery, was a pioneering operation in South Africa and was developing a new capability. It was an innovative thing, and there was one example, successful example, which could then be replicated. And as it was replicated and the skills required for heart surgery became more and more commonplace, so it shifted. And the skills got passed on from surgeon to surgeon, and what they were able to do was reduce the flexibility, reduce the variety, but increase the volume. And in doing so, you make the whole process much more efficient. So complex heart surgery today. And of course, other operations have become very, very routine. So I think in my example, I've got hernia operations, we have consistency. We have the same operation done over and over and over again, and what we end up with is in relative terms, a highly efficient operation. Okay, I said I'd touch on technology, and I've got a couple of examples of technology. The way to think about technology and process is that with high variety, low volume processes, there's relatively low automation. With low variety, high volume activities, the automation is much higher. Okay, simply because with high production, what you're doing, be it of services or products, what you're doing is repeating the same thing over and over again. If you're repeating simple activities over and over again, they lend themselves to automation. With services and operations production, which is a very high variety, low volume, then what you end up with is lots of different things happening, lots of different complex tasks, and relatively low automation. What you also have is scalability. So with high variety, low volume, things can't be scaled very easily. They're all one-offs, they're all unique to specific customer or client requirements. With high production, you can scale things up potentially as far as the automation will allow you to. Another aspect to think about a bit more critically is about the connectivity. So although projects and services, with professional services, tend to have lots and lots of interlinked activities, the coupling or connection between those activities is relatively loose, which means that they can shift and change and alter to meet different customer or client requirements, and are therefore very flexible. With automated activities where you have high volume and low variety, then the activities, the parts of the process are very tightly coupled, what's called tight coupling. This means that they can produce huge quantities, but if anything goes wrong, this can create major problems for the operation. Examples: over time, banking has shifted from what is largely personal activity to something which is virtually automated. So there's been news just the other day, in fact, I heard some news report about how many bank branches have been closing down on the high street in the UK over the last year or two. Basically, people do all their online transactions, their banking transactions online. I do, and I'm sure most of you do. So bank branches aren't really required very much. What this has led to is huge amounts of efficiency for the banks. They can create very efficient processes, thereby increasing their profits and maybe reducing the cost to the customer. So with a branch, we have a certain cost per transaction. Telephone banking, which came in the late 80s, early 90s, massively reduced the cost per banking transaction because, of course, there was no direct face-to-face contact. One person could deal with transaction after transaction after transaction, and the transactions could increasingly be automated. With cash machines, we have even less interaction. The process is very, very automated, although cash machines are relatively inflexible. As I was saying before, automation leads to relative lack of flexibility. With internet banking, transactions are incredibly cheap. So technology massively reduces processing costs. Another example, we're very, very familiar with self-service checkouts. They've appeared in supermarkets everywhere. And self-service checkouts reduce the need for customer interaction with staff and mean that customers take over that role, and in doing so reduce the cost per transaction. Okay, people, as the last couple of slides implied, are also impacted by process design. So when we think about people in an operation, we often think about job design. So the job design has impacts on these things. The key 5 objectives of all operations: quality, speed, dependability, flexibility, and cost. Okay. People also, when they're interacting with customers or interacting with machines, have a health and safety consideration. And there's lots of impacts between technology and people and process on the working life. So, for example, shift working has a major impact on people's quality of working life. The use of technology enables work to invade people's home life, and this can have an effect on their quality of working life. Okay, so again, let's look at our box of volume and variety dimensions. And with project type activities, the division of labour is very broad. So there's lots of different specialised activities or lots of different highly skilled activities in projects which are all interrelated but all distinct. And this requires a lot of often discretion and a lot of skill from the people participating in these kind of activities. With mass production and continuous production and mass services, the division of labour, if there's any labour at all, is very narrow. Job definitions for projects are highly flexible. For professional services, very flexible, have a lot of autonomy. For mass production, mass services, job definition is very closely defined and specified. You do one simple thing and you do it over and over and over again. And finally, with job commitment, well, with projects, with professional services, we have very task-based activities. People tend to be highly committed. They are required to express themselves, employ discretion, and so as it's shown on that chart there, they have an intrinsic job commitment. With process-based activities, with mass production, mass services, what's the motivator? The motivator often is pay, little else. You're doing the same thing over and over and over again. Okay, a little bit about process design in detail. So the way processes designed are through mapping. So we tend to map processes. So when you come to your assignments, one of the things I suggest you do is think about trying to express the operation in terms of a diagram which sets out the different activities that are occurring within the operation. Typical symbols, there's some of them, you can find plenty more in the textbook, give you some idea of the kind of different activities you'll find within an operation. These are scientific management type activities. People also sometimes use systems analysis, and these are some of the symbols which you might find from systems analysis. Both are fine. You can use either or. I'm happy with either, and they're all pretty straightforward. Typically, I would probably use scientific management type process maps. Here's an example. There's the overall operation for making customized sandwiches. Materials, sandwich materials and customers go into the process, assemble sandwiches, and serve customers come out of the process. So the overall transformation model looks something like this. Then within that, you've got a number of operations, micro operations. The materials are prepared, the ingredients are prepared, they're assembled to the specific requirements of the customers, and then the staff take payment and hand over the finished sandwich. Pretty straightforward thing. Something you might find in Subway or Pret a Manger, somewhere like that. Okay. Now, what you can do is break down each of these micro activities or micro operations into very detailed operations. And here's an example there. I won't go into the detail of that. You can see for yourself. And what you do is you just map the process. What's going on in the process? What different activities are happening? What are the connections between those activities? You've got an input, an output, and a variety of interconnected activities within that. So this might be a kind of jobbing activity or a batch process. Okay, so what we've talked up to now about is process types, the broad process types. You'll recall from that very first slide I had that there were a number of different process types set out against those. We had project processes, or fixed position, I think it was fixed position processes, cell production, process production, so all sorts of different process types. What that's referring to is layouts, and functional production is the other one. What that's referring to is layouts. So processes are laid out, and what I'm talking about by layout is the physical layout of the operation. So if you're looking at an operation and trying to make sense of it and understand it, yes, you can map it. You can map it in an abstract way, but you can also look at it in terms of the physical relationship between the different parts of the operation. So layout involves, as I said here, the relative positioning of transformed resources, the things which are being changed within operations, and the allocation of tasks which together dictate the flow of the transformed resources. That should be first one should be transforming resources. I'll correct that when I change these slides in future. So we have the relative position of the transforming resources and the allocation of tasks to those transformed resources, and those determine the flow of the transformed resources. Okay, so there's the different functional layout types, and we have the manufacturing ones. Project processes are normally fixed position, so everything comes to the project, wherever it is. Jobbing type processes, they can be fixed position or a kind of functional layout. Batch processes are frequently cell layout, but sometimes functional layout or even occasionally product layout. And mass services are normally either cell or product layout. And you can do the same thing with services. So professional services are either fixed position or functional layouts. Service shops can be a range of functional cell type layouts, and mass services a range of cell or product layouts. Okay, so what do we mean by those? Fixed position layouts is where the product, material, or people being processed stay stationary. They don't move. Okay, all the transforming resources come to the thing being changed. Okay. So why would that happen? Well, often the product is too large to move. Can't move a building easily. Patients in surgery might be very delicate or too delicate to move. Customers don't want to be moved around. The key points are you need plenty of space for these kind of operations. So they're very inefficient. They're very inefficient because partly because of the many different activities which are required, which are all unique to the operation, but also because they require large amounts of space, often very controlled space. So plenty of space required. All suppliers, all contractors and so forth have to have access to their part of the project, and there's minimal movement of machinery and people. Here's an example of which I drew out of the book of attempting to make something which you regard as very much a fixed layout service, I guess, more of a efficient activity. So typically specialized surgery might be carried out on one patient, and that patient would just be operated on. And what hospitals are trying to do is make that very inefficient process a bit more efficient by making better use of the surgeon's time, better use of the anaesthetist's time, and better use of the space. Functional layouts. This is where specific processing needs or requirements for items are processed, and their processing determines the layout decision. Why? Okay, why? Because different products and customers have different processing needs. So customers or products take very different routes through the layout, through the process, depending on what's required. Key points are that similar processes tend to be located together. Products, customers or information flow are routed from process to process according to their needs, and flow patterns tend to be very complex in these kind of activities. Okay, right, so here's an example of a functional layout operation. This is a library, a little bit dated because I think I've got CD-ROM shown in here, but this is straight out of the textbook, so you can read about it there. So there we are, I have different areas or functions within the operation, and you can see these listed here. Now, the interesting thing is how customers will use an operation like a library. They'll move around all over the place, and they'll go to different parts or different parts of work, different work activities, just like you would in a small carpentry outfit or a pottery manufacturers or something like that, where the different, depending on what's required, the work or the materials move from part to part to part and receive some kind of work before they move to the next part. but those wouldn't be common to all the different products being produced. So there we go. That's a functional layout. Another example is a department store. They have different functions, or stores within the store, if you like, and one of those is sports shop. Okay, product layout. This is much more what we're familiar with and think about when we're thinking about operations. So plant equipment facilities are located or laid out in a sequence. So a production line for processing materials or people or information. This is about logical unidirectional flow. One point to the next point to the next point. And what we have is repetition. Low variety, high repetition. This is the important thing about these kind of layouts. Materials, customers or information flow along a process line. It's sometimes called line layout. The flow is clear, predictable, and easy to control, and it's used for all kinds of standardized products where those are required. Then we have a car manufacturing, and you can have them in varieties of ways. So although it seems in some ways that this is a kind of a fairly straightforward kind of operation, there's always room for improvement and innovation, as Toyota showed in their sideways assembly plants. And there we are, again, a Toyota example of how you can tinker with this kind of operation, this kind of layout, in order to gain operational efficiency advantages. Although it's a very efficient kind of production approach or service delivery approach, there's always room for improvement. As Toyota shows. Another example is an army induction centre. So you've seen any kind of films of new recruits going into the army. They go through various processes, and those processes are always the same. And those are shown there. And in goes the recruits, one after the other. Oh, okay. Now, something which is relatively new. I say relatively new. Probably the last 30 or 40 years has become more and more commonplace. It's something called a cell layout. This is a way of thinking about production which tries to gain a bit of flexibility and a bit of reduce the path dependency of and the connectedness of line production, but increase, and at the same time and by the same token, increase the increase the productivity of functional production. So materials, people or information are moved or processed by pre-selection. So they move within to one part of the operation. So why is this useful? It's about facilities and their needs being located in one area. A cell, that's why it's called cell layouts, where all the operation can be completed. So it's all completed in one place. Cell layouts may have a process or a product layout, be part of a process or product layout. After being processed, the transformation process may go to another cell, and often the case, and is an attempt to bring some order to the complexity of functional process layouts, really. Here's an example of functional layout which has been changed by creating a cell layout. And there we are, two cartoons showing that. Okay, now, although I've kind of subdivided these into different parts, something to bear in mind, and when you come to analyse operations, something you should think about, is that operations, major organisations often have many operations occurring within them. Take the university as an example. The university has big lecture theatres, has smaller classrooms. So the big lecture theatres are mass services, the smaller classrooms are more of a service shop kind of arrangement. And then we have academics in offices, and the offices are fixed layouts where we have fixed positions where we have all the customers coming to the operation. Okay? So within the university you have lots of different layout types. Within a hospital, as an example of a hospital, you can see different layout types there. A restaurant example here, sort of thing you might find in a museum or a gallery. You'd have different kinds of restaurant offerings to different for different kinds of customers. We have this again in the university. So in University House, we have on the ground floor, not University House, sorry, the University Centre. On the ground floor, there's a big buffet area, a big self-service area, buffet area where and service line area where you guys can receive your get your food, your sandwiches, and what have you. And then there's the floor up. There's a buffet, and then top floor in that building, it's white tablecloths and sit-down restaurant service. So the top floor, we've got a fixed position layout, service restaurant. On the floor below it, we have a cell layout buffet, and on the ground floor where you go, and also in the basement where you guys would go, there's cafeteria type layouts. The kitchen itself might be common for all three of those kind of services, and will be a functional kind of layout, as shown there. Okay, so there's a strategic decision which operators require, which is deciding on the facility's layout. So this is a strategic activity, and starts really with thinking about volume and variety. Where is our operation on the volume and variety dimension, and what are our performance objectives? What are we interested in achieving as part of our activity? By performance objectives, I mean the 5 performance objectives of all operations. So quality, dependability, flexibility, cost, and speed. Those are the 5 key performance objectives. So those 2 aspects go into thinking about the process type. So decision 1 is the process type. And that is, if it's manufacturing, is it a project, jobbing, batch, mass, or continuous process? And if it's services, is it professional services, service shops, or mass services? So that's the first decision so this in turn leads to the second decision. What's our basic layout type? Again, the strategic performance objectives come into play, and pretty much this is determined by the type of process type we have. This will lead to a basic layout type, such as fixed position, functional, cell, or product layouts. This in turn leads to a detailed decision about the layout. It's determined partly by what space we have, what the nature of the facilities we have to operate in are, and also the physical positioning of all the transforming resources. This drives the flow of transform resources, which are materials, people, or information, through the process. Okay, so the questions I started with were, what is process design? What is the role that technology plays in process design? What are the human implications of process design? How are processes designed in detail? How can they be mapped? Then, what are the kind of layouts we use for different kinds of process? Okay, so hopefully you can answer those questions now. Next time we'll be looking at capacity, and you need to read chapter 8 for that. Okay, thanks very much.